So next up, we're going to talk about the idea of an indeterminate form. An indeterminate form is anything where you essentially wind up with two things that contradict each other in the mathematical world. Really what it boils down to is you attempt to use the direct substitution property and the direct substitution property doesn't work. An example of a time when the direct substitution property does not work would be the limit as x approaches 2 of x cubed minus 8 over x squared minus 4. If you attempt to use the direct substitution property on this, direct substitution property says just go ahead and plug in the number that x is approaching. So if you plug in x equals 2, we would get 2 cubed minus 8 over 2 squared minus 4, and that would be 0 divided by 0. Now normally when we see 0 divided by anything, we would expect the answer to be 0, but anything divided by 0 tends toward infinity. So 0 divided by 0 would be considered an indeterminate form. Now, some time ago, we did have a way of dealing with this, and the way that we dealt with this is by factoring both the numerator as well as the denominator. So, denominator is a difference of 2 cubes. If you need to use synthetic division to figure out where all this is coming from, feel free to do so. And as I frequently say at parties when I go to parties, difference of perfect squares factors into binomial conjugates. So we get x minus 2 and x minus 2. Those will cancel each other out, allowing us to retry the direct substitution property. And if we try the direct substitution property in this form, we get a much more favorable result, DSP. So that'll be 2 squared plus 2 times 2 plus 4, which is 12, all over 2 plus 2, which is 4. Simplify the 12 over 4, and we get 3. Now, as far as indeterminate forms are concerned, there are a total of 4 categories of indeterminate forms. Indeterminate forms can only exist as limits that when you attempt to use the direct substitution property, you wind up with one of the following 4. So first one is the indeterminate quotient. Indeterminate quotient takes on 2 different forms, either 0 over 0 or infinity over infinity. Both of those can be evaluated using other techniques. We have the indeterminate product. Indeterminate product takes the form 0 times infinity. 0 times anything should be 0, and anything times infinity should be infinity. We have the indeterminate difference. Indeterminate difference takes place anytime you attempt to subtract infinity from infinity. And finally, the indeterminate power. The indeterminate power, there are 3 different forms: 0 to the 0 power, infinity to the 0 power, or 1 raised to the infinity power. In all 7 of these forms, it is impossible in its current form to figure out what it is. So from this, we're going to introduce a new rule. The new rule is known as L'Hopital's rule. You can tell it's French because there's a bunch of letters in it you don't pronounce. L'Hopital's rule states that if you start with an indeterminate quotient, so given that the limit as x approaches a of f of x over g of x is an indeterminate quotient, so either infinity over infinity or 0 divided by 0, it is possible to evaluate by doing the following. Limit as x approaches a of f of x over g of x would be equal to the limit as x approaches a of f prime of x over g prime of x. L'Hopital's rule states that if you take the derivative of the top and the derivative of the bottom of an indeterminate quotient, the value of the limit does not change. To give you an idea, I'd like to consider the limit that we had just a moment ago. Limit as x approaches 2 of x cubed minus 8 over x squared minus 4. According to L'Hopital's rule, which we're going to indicate by using an H with a circle around it for Hopital, that says that if we differentiate the top and we differentiate the bottom, we should wind up with the same value for the limit. So differentiate the top and differentiate the bottom. So this would be the limit as x approaches 2 of derivative of the top, 3x squared, derivative of the bottom, 2x. If we attempt to use the direct substitution property again, we wind up with 3 times 2 squared over 2 times 2, which when simplified gives us 3. You'll notice back up top that by doing the algebraic method, we got literally the exact same result. So hopefully this solidifies in your head that it actually works.